Imagine a time before Earth, before the Sun, before the planets we call home. A time when the universe was a chaotic swirl of gas and dust, waiting for a spark to ignite something extraordinary. 4.5 billion years ago, our solar system was born from this cosmic chaos, a violent, awe-inspiring process that shaped the sun, the planets, and even the possibility of life itself. But how did it all begin? What forces sculpted the worlds we see today, and what secrets still linger in the shadows of our cosmic neighborhood? Welcome to a journey through time and space, where we'll uncover the shocking origins of our solar system. From the explosive birth of the sun to the fiery collisions that forged the planets, this story is one of destruction, creation, and mystery. Did you know that our sun was once part of a stellar nursery, a crowded cradle of stars? Or that the planets we know today survived a gauntlet of cosmic violence to find their place in the heavens? In this documentary, we'll dive into the science, the surprises, and the unanswered questions that make our solar system one of the universe's greatest wonders. The problem is clear. The birth of a solar system is a complex puzzle, pieced together by astronomers over centuries. How did a cloud of gas transform into the intricate dance of planets, moons, and comets we see today? And what can this story tell us about our place in the cosmos? Join us as we explore the shocking secrets of the sun and planets, revealing the forces that shaped our world and the mysteries that still elude us. To understand the birth of our solar system, we must travel back 4.6 billion years to a time when the universe was young and restless. The Milky Way, our galaxy, was already a sprawling metropolis of stars, but in one quiet corner, a vast cloud of gas and dust, called a nebula, floated in the void. This was no ordinary cloud, spanning light years. It was a cosmic nursery, pregnant with the potential for new stars and worlds. The story begins with a trigger. Astronomers believe a nearby supernova, a star's explosive death, sent shockwaves rippling through the nebula. The death of one star can spark the birth of another, says Dr. Jane Greaves, an astrophysicist at Cardiff University. These shockwaves compress the nebula, causing it to collapse under its own gravity. As it shrank, the cloud spun faster, much like a figure skater pulling in their arms. At its center, a dense, hot core began to form, the seed of our sun. This process wasn't unique. The universe has been birthing stars this way for billions of years. But what made our solar system special? The answer lies in the leftovers. As the protosun grew, it didn't consume all the nebula's material. Dust and gas swirled around it, forming a flattened disk, a protoplanetary disk. Within this disk, the seeds of planets began to take shape. Tiny grains of dust collided, sticking together to form pebbles, then boulders, and eventually planetesimals, rocky bodies the size of asteroids. This was a chaotic era, known as the accretion phase. It was a cosmic demolition derby, explains Dr. Sean Raymond, a planetary scientist. Planetesimals slammed into each other, sometimes merging, sometimes shattering. Over millions of years, these collisions built the cores of planets. But the process was far from orderly. The early solar system was a battleground, with competing forces of gravity, heat, and radiation shaping its fate. Key figures in astronomy have helped unravel this story. In the 18th century, Immanuel Kant and Pierre-Simon Laplace proposed the nebular hypothesis, suggesting that the solar system formed from a collapsing cloud. Their ideas laid the groundwork for modern theories. By the 20th century, scientists like Viktor Safronov refined these models, describing how planets grew through accretion. Today, advanced telescopes and computer simulations allow us to peer into the past, confirming that our solar system's birth was both violent and miraculous. Let's dive into the heart of the story, the step-by-step creation of our solar system. The process unfolded over millions of years, but we can break it into key stages, each more astonishing than the last. At the center of the collapsing nebula, the protosun grew hotter and denser. After about 100,000 years, it reached a critical point. nuclear fusion ignited. Hydrogen atoms fused into helium, releasing a torrent of energy. The sun was born, a blazing star that would anchor the solar system. The sun's birth was like flipping a switch, says Dr. Meredith Hughes, an astronomer at Wesleyan University. It lit up the disk and set the stage for everything else. But the young sun was wild. It spewed intense radiation and solar winds, stripping away much of the gas in the protoplanetary disk. This shaped the planet's fates. Close to the sun, only rocky materials like silicates and metals could withstand the heat, forming the seeds of Mercury, Venus, Earth, and Mars. Farther out, where it was cooler, gas and ice survived, giving rise to the gas giants, Jupiter and Saturn, and the ice giants, Uranus and Neptune. Within the protoplanetary disk, planetesimals grew through collisions. Over millions of years, some became massive enough to attract others, forming planetary embryos. These embryos collided, merging to create the planets we know today. But the process was brutal. Earth, for example, likely formed from dozens of smaller bodies smashing together. One colossal impact, about 4.5 billion years ago, is thought to have created the Moon. A Mars-sized object, nicknamed Theia, struck the young Earth, ejecting debris that coalesced into our Moon. Jupiter, the solar system's heavyweight, played a pivotal role. Its massive gravity stirred the disk, preventing a planet from forming in what is now the asteroid belt. Jupiter was like a cosmic bully, says Dr. Raymond. It shaped the architecture of the solar system. Jupiter's influence also sent smaller bodies careening inward, bombarding the inner planets in an event called the Late Heavy Bombardment, about 4 billion years ago. Evidence of this violent period is etched in the craters of the Moon and Mercury. Surprisingly, the planets didn't stay where they formed. Computer models suggest that Jupiter migrated inward, then outward in a process called the Grand Tack. This reshuffled the solar system, scattering smaller bodies and influencing the orbits of other planets. Saturn, Uranus, and Neptune also shifted, with Neptune likely swapping places with Uranus. The early solar system was a dynamic place, notes Dr. Greaves. Planets were on the move, like pieces on a cosmic chessboard. As the planets settled into their orbits, the solar system entered a cleanup phase. Leftover debris, comets, asteroids, and small planetesimals, was either swept up by planets, ejected into the distant Oort cloud, or scattered into the Kuiper Belt. This period, lasting hundreds of millions of years, gave the solar system its modern structure. But not all mysteries were resolved. Why did Mars remain so small? Why are Uranus and Neptune so different from Jupiter and Saturn? These questions continue to puzzle scientists. The final act of the solar system's formation set the stage for life. Earth's unique position in the habitable zone, where liquid water could exist, was critical. Comets and asteroids, rich in water and organic molecules, bombarded the young Earth, delivering the building blocks of life. We're all made of stardust, says Dr. Hughes. The elements in your body were forged in stars and delivered by cosmic collisions. By 3.8 billion years ago, the first simple life forms appeared, a testament to the solar system's remarkable journey. The culmination of this story is the solar system we see today. 8 planets, countless moons, and a star that sustains life. But the journey was anything but predictable. It was a saga of chaos, destruction, and chance. A cosmic dance that could have ended very differently. Today, our understanding of the solar system's origins is deeper than ever, thanks to cutting-edge technology and exploration. Telescopes like the James Webb Space Telescope peer into distant star-forming regions, offering glimpses of protoplanetary disks around young stars. These observations confirm that our solar system's birth was not unique. It's part of a universal process. We're seeing baby solar systems in real time, says Dr. Klaus Pontoppidan, an astronomer at the Space Telescope Science Institute. Missions to our own solar system have also revealed stunning insights. NASA's Juno spacecraft has uncovered secrets about Jupiter's core and magnetic field, shedding light on its formation. The OSIRIS-RX mission collected samples from the asteroid Bennu, which may hold clues to the early solar system's chemistry. Meanwhile, the New Horizons probe explored the Kuiper Belt, revealing icy worlds like Pluto that are relics of the solar system's youth. But challenges remain. One major puzzle is the search for Planet 9, a hypothetical world lurking in the outer solar system. Its existence could explain odd orbits in the Kuiper Belt, but it remains elusive. Another mystery is the Sun's stellar siblings. Our Sun likely formed in a cluster of stars, but where are those siblings now? Astronomers are combing the galaxy for clues, using data from the Gaia spacecraft to trace stellar origins. Public interest in the solar system is booming. Citizen science projects, like those on Zooniverse, allow anyone to analyze telescope data and contribute to discoveries. Meanwhile, private companies like SpaceX are pushing the boundaries of exploration, with plans to send humans to Mars. We're on the cusp of a new era, says Dr. Raymond. The solar system is no longer just a place to study, it's a destination. Yet, not all trends are positive. Budget constraints and competing priorities can limit space exploration. And the growing problem of space debris threatens future missions. Still, the drive to understand our cosmic origins remains strong, fueled by curiosity and the promise of new discoveries. What does the future hold for our understanding of the solar system's birth? The next few decades promise to be transformative. Upcoming missions, like the European Space